Yep, your car is red is the hypothesis. And then what's my conclusion? You like red. Notice how I color-coded them so you can see where I put them in the sentence. So if your car is red, then you like red. This is not necessarily true, I tried to make it simple so that we could write simply. All right, the converse. What do we do with the hypothesis and the conclusion when we're dealing with the converse? We switch them. What did I tell you to remember? To help you remember, I told you a personal story. Noah?
Shoelaces.
My shoelaces. I switched my converse shoelaces. Okay, so you remember you're going to switch. So what will come first? If you like red, then your car is red. You flip them, okay? You flip them. Switch, flip. I think exchange is the word in the book. All right, inverse. What do we do with the inverse? You negate them. Yeah, you make the negative. How did I tell you to remember that you negate? Starts at let's think. Yeah. Inverse, you negate. The first letter here when you say the word inverse is the letter N. You don't really hear the I, you hear N. Okay? So when we negate, we go back to the original conditional, which would be if your car is red, then you like red. So what would the inverse sound like? Yeah, if your car is not red, then you do not like red. All right, and what do we do for the contrapositive? You switch and negate. Switch and negate. So what will happen is you can do one of two things. You can look at the converse, which is already switched. Then you would just negate it. Or you can look at the inverse, which is already negated. You would just switch it. Okay? So I personally like to look at the converse, which is up here. If you like red, then your car is red. It is already switched. You need to negate it. So instead of if you like red, it's going to be if you do not like red, then your car is not red. Switch and negate. How did I tell you to remember contrapositive? It's the longest word. You do the most work. Exactly. So this is on your quiz tomorrow. I will remind you that there is a Kahoot online. It's already made up. This lesson, I will explain how I put problems from this lesson on your Kahoot. It was hard to do. And it will help you best with 2.1 and 2.2 and somewhat help you on 2.4. I'll explain why when we get to it. Okay? Difficult to put on the Kahoot because we are going to be solving algebra equations, and you justify the step. So you'll solve, and then you'll write what step you used. That's kind of hard to do on Kahoot. I did it to an extent, but not perfectly. Okay, and I'll explain it when we get there. So we're going to start on the top of our notes on 2.4, Algebraic Reasoning. Algebraic Reasoning. Here's some definitions. We're going to pause before we get to that one. What's the first word on your paper? Equation. What is the root word in equation? Equal. Equate, that's fine. Equal. So here is what I need you to understand. Is this an equation? It's not. Some of you put this on your test, the last test. You would add a bunch of things, have no equal sign, and then somehow at the end you were like, well, x equals 2. How did you not have an equal sign, and now you have an equal sign? Does this make sense? Does it? Where's the equal sign? There's no equal sign. How do we pop out an equal sign out of nowhere? Okay? So it does not make sense. So if you ever read on a paper where I write, where is the equal sign? You are one of the culprits of this. Okay? Where is the equal sign? That's what I'm talking about. You can't solve an equation without an equal sign. Okay? Here's the official definition of equation. You want to write it in the top. A statement that shows the values of two mathematical expressions are equal. A statement that shows the values of two mathematical expressions are equal. It's indicated by an equal sign. the next one is going to be a variable. Please only write what's in parentheses. Oh, sorry. Solve an equation. Sorry, here's the word variable. Find the value of the variable. That's all I want you to write. Okay? Yes, you find what values fulfill a condition stated in the form of an equation, but I want you to write what's in parentheses. Find the value of the variable. All right, the last, you're going to cross out the word variable. So cross out the word variable. You're going to write the word formula. That was just a clinical error on my part. So you're going to write formula instead of variable. Yes, sir. This part will, not the terms, but these will. All right, formula, an algebraic equation that relates two or more real-life quantities. An algebraic equation that relates two or more real-life quantities. And then we're going to drop into the section below. Algebraic properties of equality. You're going to skip the first line. So skip the first line. We're going to go on to the second one. It just printed weird. Sometimes it does that. All right, so the first property of equality is going to be the addition property. Please write it again on the second line. So you're going to write it on this line. Okay? Addition property of equality. Write it on the second line. So this one. Sorry, I have red on my finger. So addition property of equality. Please make sure you write of equality. Here's why. Okay, what word do you hear when you say equality? Equal. So what happens is if you have A equals B, look at our equation. What happened to A and B? They equal each other. What else happened?
That's an addition.
They're on different sides. What else happened to them?
They got added by C.
They both were added by C. The addition property of equality, if you have to write the statement, you have to write of equality. Here's why. If you just write addition property, guess what the addition property is? That's the addition property. What's 4 plus 2? 6. So you cannot just write addition property. You have to write of equality because it happens to both sides. I'll explain when we get there. Next one is the subtraction property. So this is where we subtract on both sides. So subtraction property. Make sure you write subtraction because there's another one similar. Subtraction property of equality. All right, we have addition and subtraction. What do you think is next? Multiplication property of equality. This is where we multiply on both sides. And last on your page, division property of equality, which is where you divide on both sides. And then this next one is already filled in for you, and it is the substitution property of equality. I will explain it. So whenever you add on both sides, that's the addition property of equality. Whenever you subtract on both sides, that's the subtraction property of equality. When you multiply on both sides, that's the multiplication. And then here's the thing. You're going to write at the bottom where it says substitution property of equality. This is always the last step. So when you get down to x equals a number, it will always be the substitution property of equality. All right, we're going to do the problem below. Okay? you have done this before. You're just going to write what step you used. Okay, so let me show you how you're going to want to do this. I gave you boxes. You do not have to use them. You can use them any order you want them. So the left side is for you to do the math. The right side is so you can write what step you used. For every step, you'll write, like, so if we add on both sides, you're going to write, we use the addition property of equality, and so on. Okay, so let's do this. First, write down the problem. We got 3x plus 2 equals 23 minus 4x. Here's what I tell everyone to do first. What is the smallest x value? Negative 4x is actually smaller. If you have negative $4 in your bank account and I have $3, I am the rich man in this scenario. All right, so we decided negative 4 is the smallest x. So how do we move negative 4 onto both sides? You add 4. So if we're adding 4x onto both sides, all right, so if we add on both sides, you're going to write the addition property of equality. Okay, I don't mind if you abbreviate, but you need to at least write add and then property of equality. Okay, property of equality. Then we come down to this step. What is 3x plus 4x? 7x. Then we have plus 2 equals 23. What will we do next? We'll end up subtracting. So if we subtract on both sides, what number are we subtracting? 2. What property is this? Subtraction. Pause. So put down your pencil for a second and look at the screen. If I just write sub property of equality, will that suffice in explaining which property I'm using? No, because how many properties start with sub? 2 of them. So please write subtract at least. Okay, subtract. Yes, sir. Yeah, that's fine. Subtraction, property of equality. So when we subtract, we're going to have 7x equals 21. What will we do from here? Divide by what number? 7. When we divide on both sides, this is called the division property of equality. And then once we divide, what do we get for x? Equals 3. What did I tell you is when you get down to x equals a number, what do we write as the justification? Yeah, the substitution. Please don't write substitute. Property of equality. And that would be the answer. This is why I said this section was hard to put on Kahoot, because part of it is, yes, solving an equation, but the other part is justifying your steps. And I'll explain what I ended up doing. Are there any questions on this problem? This is why I figured you could be quizzed on this, because this is just algebra. We've been doing it in this class. You did it last year. The only extra is writing that property. Okay, we're going to talk about the distributive property. It's already on your paper. It's on the next page. Next page. So it's already filled in for you. The distributive property, when you distribute, are you adding, subtracting, multiplying, or dividing? You're multiplying. So that's why when you see on this page A times B plus C, when you distribute, that turns into AB plus AC. Because A times B is AB, A times C is AC. And the same thing in the second scenario. A times B is AB, A times negative C is negative AC. Okay, so you're going to be using distributing in this section. Okay, so all you do when you distribute, you write distributive property. It is not of equality. Can anybody guess why? No. There will be an equal sign. Look at this example. There's an equal sign.
Oh, it doesn't happen if.
No. It doesn't happen on both sides. You know how of equality? When we write of equality, we're saying we're doing it on both sides of the equal sign. Whereas distributive property, like in this one, it doesn't deal with both sides. It deals with that one side. Okay? So we're looking at this example. It's right under the notes. We're going to write down our problem. Negative 5 times 7w plus 8 equals 30. What will my first step be? Distributive property, yeah. So yes, we're going to end up multiplying. Make sure you distribute to both portions. What is negative 5 times 7w? Negative 35w. Negative 5 times 8 is negative 40. All right, so what property did we just use? The distributive property. So the distributive property is just the distributive property, no of equality. All right, once we get down to negative 35w minus 40 equals 30, what do we do next? Add what number? 40. Which would make that the addition property of equality. All right, so that means we have negative 35w, which will equal 70. All right, what do we do here? Divide by negative 35. Which makes that the division property of equality. All right, so I get w equals, what is 70 divided by negative 35? Negative 2. So what property is this? Substitution. Property of equality. All right, are there any questions on solving these equations and justifying? Okay. So here's what we're going to do. We're going to flip to the next page. This next page, you're going to talk about 3 more properties, which you already know what they are. This is just basic review. The 3 properties, reflexive, symmetric, and transitive. We actually talked about transitive yesterday. Okay, when you think of a reflection, when you look, Tia, when you look in the mirror at your reflection, who do you see? You. So reflection, a reflexive property, you'll see the same thing equal to itself. A equals A. AB equals AB. The measure of angle A equals the measure of angle A. So you want to write that in the first blank. That's why I put a blank there. You write it. Reflexive property. Here's why it exists. You're going to be given these pictures later on in math that look like this. Okay? 2, a rectangle and a square, next to each other. And it's hard for some students to realize, give me a number. 6, sure. Let's say this was 6 feet wide, okay? This wall that they share. So then what would the length of the wall on the other side be? 6 feet, because guess what? It's a reflexive property. It's the same wall. The wall equals itself. Do you know what I'm saying? Students find this hard later on in geometry. That's why we have to say it out loud, okay? So that's the reflexive property. The symmetric property is the next property. This is a property where things flip. If A equals B, then B equals A. If AB equals CD, then CD also equals AB. If the measure of angle A equals the measure of angle B, then in the same way, the measure of angle B equals the measure of angle A. You learned this when you learned, let's say 4 equaled x, and you were solving an equation. Your teacher probably told you she preferred, or he preferred x to be on the left side. Can we do that? Yeah, we can. So x would equal 4. This is a symmetric property. It is not the reflexive property. The reflexive property would say 4 equals 4. This property says 4 equals x and x equals 4. This is symmetric. Okay, the flipped around version. The last is the transitive property. We talked about this yesterday with ages. We can also do it with grades. If Jamari gets the same grade as Alana, and Alana gets the same grade as Mackenzie, then we know Mackenzie and Jamari have the same grade as well. That's a transitive property. If these 2 equal and these 2 equal, that means the first and the last also equal. Okay? These are the 3 properties. This is all that's left of the properties. So we're going to use them on the next page. Okay, so flip. This is more so what your Kahoot will look like. Okay, so what will happen is, on the Kahoot, it will say, what did they do between steps 1 and 2? And you'll have to choose which property was used. Okay, they already did the math for you. You have to decide the property. So what does it look like they did between step 1 and 2? They distributed. They said, you know what, 4 times x, sorry, 4. Where am I getting 4 from? 2 times x is 2x. 2 times 3 is 6. So they distributed on both, just one side, sorry. Distributed. Between the next 2 steps, did the right side change at all? 5x plus 4, and 5x plus 4. Did they change? No. On the left side, things changed. The 2x remains, but they have 6 minus 5, and in the next step, they have plus 1. What happened there? Yeah, well, they added, subtracted, yeah. So here's what this is called. It is not the subtraction property of equality, because they did not do it on both sides. You wouldn't even have to put subtract. It's called combining like terms. So you would write combine like terms. So whenever they just add or subtract on one side, that's called combining like terms. On your test or quiz, I won't require you to write that, but on something like this, you should. In the next, what does it look like it's happening? It's even color-coded on my screen. They're subtracting the 2x. They're doing that so they can get this 2x onto the other side. Okay? So if they subtract 2x on both sides, what property is this? The subtraction property of equality. In the next step, it went from 2x minus 2x plus 1 to just 1. And it went from 5x minus 2x plus 4 to 3x plus 4. So what happened between the 2 steps? They already did that. It's still called combining like terms. They subtracted here, they combined the like terms to get to this step. Because 2x minus 2x cancels out. All you drop down is the 1. 5x minus 2x will get you the 3x. They already did the subtraction. We just combined the terms. All right, now in the next one, what happened? Now that's the subtraction property of equality. In red. All right, and then again, they went from 1 minus 4, and they combined to negative 3. They went from 3x plus 4 minus 4 to just 3x. This is, again, they've already done the subtraction. This is just combining like terms. All right, and then we're almost finished. We got 3 left. What is happening here? Negative 3 divided by 3 equals 3x divided by 3. The division property. Yes, Ian? What? All right, now. Once we divide, we get negative 1 equals x. All right, so is this the end of our road?
No.
Well, I mean, yeah, it is. Do we get x alone? Yeah, so this is the substitution property of equality. The last one I would switch. The last one is not the substitution property again. What changed between the first and second step? They flipped it. So, symmetric property. Symmetric property. Just symmetric property. All right, so all they did was say, I want to put x on the left, so they flipped it. Okay? So that is the first portion. It's more like 3/4 of the portion. Now we're going to do a different part. Okay, so we're going to do our next example. Interesting. You get a raise. We're going to do half of this example. You get a raise at your part-time job. To write your raise as a percent, use the formula. So write down the formula. P times R plus 1, and it will equal N. P times R plus 1 and equals N. Where P is your previous wage, R is the percent of increase as a decimal, and N is your new wage. Solve the formula for R. So what is the goal in this problem right now? Yeah, to get what? To get what? What does it say? To solve for R. We're solving for R. We want R by itself. We want one R. So before you do anything, some of you think that you want to distribute. We would not want to do this. This would make the problem harder if we did that. We already have one R. Do you understand what I mean by that? There's no number in front of it. There's no letter in front of it. We already have R simplified. So what we need to do is recognize R is attached to R plus 1. It's inside of those parentheses. So the best goal right now is to get these parentheses alone. So what is happening? What is the letter P doing in the parentheses? It's multiplying. Anytime you see a number or letter in front of parentheses, that's multiplication. So how do we get rid of multiplication? By dividing on both sides. Which are we trying to get rid of? P or the R plus 1? P. So we're going to divide by P on both sides. We don't have to justify. It doesn't say justify, so we don't need to. The letter P will cancel out. We have R plus 1 equals N divided by P. Now at this point, do I need the parentheses, you think? No. There's nothing being multiplied. There's nothing being divided. There's no need for them. We have R plus 1 equals N divided by P. So how do I get R by itself now? Subtract the 1. Can I subtract a number from a letter? No. So I write N over P minus 1. And that's it. What it would be asking from here is to plug in your old wage and your new wage. We're not going to do that right now. We are just doing the first part. For time's sake, really. All right, next. We're going to do, it looks like 2 of these, or however much we have time for. Then we're going to look over the homework from yesterday. 23, this is from your book, actually. What letter are we solving for? A. What do we notice about the letter A in this equation? It's in 2 places. 2 places. So we need to move it all to one place. Okay, so which one would we like to move? Sure, let's move KA. How do we move KA to the other side? Sure, let's subtract KA. So we have U equals. Are they the same exact term?
No.
No, so we just write them next to each other. BA minus KA. And then we're going to use a property. This is a property you learned in Algebra 1. You'll use it again in Algebra 2. You're going to use it in this class. Okay? I'm going to go over here and give you an example. Let's see. If I said we had 3x plus 6, you can factor out a number. Do you remember the word factor? It's okay if you don't. Factor means divide out a number. In my green box, what number do they have in common? 3. So I could divide out a 3, but guess what? Is what's in my green box, is that an equation? No, it's not. So can this 3 poof away? It can't. So we do this thing where we put 3 on the outside of the parentheses and x plus 2 on the inside of the parentheses. Because this is equivalent to what we started out with. It is the same. If I redistributed this 3, it would be the same as what we started with, 3x plus 6. Does everyone understand the concept of distributing? The opposite is undistributing, factoring. We're actually going to do that here. Okay? The difference is here we have letters. And what I just showed you, they were both divisible by the number 3. What are BA and KA both divisible by? What do they have in common? The letter A. So we are going to leave the left side alone. It's still going to be U. The right side, they are both divisible by the letter A. So we're going to divide an A. When I divided out over here, when I divided out my 3, did I throw it away? No. I can't throw it away. I need to write it on the outside. So we're going to have an A. BA divided by A, that cancels the A's out. So what's left? B. KA divided by A, K. We're almost finished. Do we have a question about this? What? We didn't get A by itself. We're almost done. So what is A doing to B minus K? It's multiplying. We still want to get one letter by itself, right? Which letter? The letter A. So we're going to leave A alone. We're going to leave that guy. But A and B minus K are multiplying times each other. So how do we get rid of B minus K? Divide on both sides. We're going to divide B minus K on both sides. That will get rid of B minus K on the right. And it will just be there on the left. So our final answer, I know I ran out of room, would be U over B minus K. And it equals A. Okay, I know I ran out of room, and I apologize. It's hard to write teeny tiny and still so you can see. All right, so we divided because they're multiplying. We wanted to get A by itself. If we divided by A, that wouldn't have helped us. Okay, so we had to move what shouldn't have been on that side. All right, now we're going to do 25. Okay, I'm going to write it out. Which letter are we solving for here? A. So what is A immediately attached to? 2, well, close, negative 2. So we want to get negative 2A by itself. Okay, so we need to move 3B and we need to move positive 2. How do we move 3B onto the other side? Subtract it. Can U and 3B be combined in any way? No. So you just write them next to each other. U minus 3B equals negative 2A plus 2. We're still trying to get negative 2A by itself. So what do we move next? Subtract 2. Can 2 be combined with U or negative 3B? No. So we just write them next to each other again. So now, have we accomplished our mission in getting negative 2A by itself? Well, we got negative 2A by itself, yes. Now we want to get A by itself, okay? What is negative 2 doing to the letter A? It's multiplying. So what's the opposite of multiplying? Dividing. So you're going to divide every single term by negative 2, and I'll show you why. I will show you why. Can negative 2 go into U? No. So you're just going to write negative U divided by 2. It doesn't really matter. Sorry, I know it's not much room. U divided by negative 2. It doesn't matter where you write the negative. It could be in the numerator. It could be in the denominator. It could be out in front. As long as there's a negative. Then you have negative 3B divided by negative 2. Can 2 go into 3? Does 2 go into 3? No, it's not a number. So here's what happens. Do you see that there's a negative over a negative? What does that make? Positive. So it's going to change into a positive 3B over 2. Then we have negative 2 divided by negative 2, which is positive 1. Now do we have A all by itself? Yes, that is the final answer. All right, we're going to pause here. We're going to pick up this tomorrow. You're going to take out the classwork from the past 2 days and switch them.